webcast discusses how to solve problems that involve the friction force. So our first problem talks about a sled moving at a constant speed over a horizontal floor, and someone is applying a force of 50 newtons to pull the sled. So let's do a force diagram for the sled. Now, since the sled is sliding at a constant speed, even before I begin to draw in the forces, I know that the net force in this situation is zero because of Newton's first law. An object, moving at constant speed, all of the forces are balanced. It's at equilibrium. So I'll begin with the weight of the sled, which is the gravitational force being exerted on the sled by the Earth. That's given to us as 300 newtons. And they tell us that someone is applying a force. So there's an applied force on the sled, I'll say by a person, and that's given as 50 newtons. Now, in the vertical direction, the gravitational force is balanced by a normal force being exerted on the sled by the floor. These two vertical forces are balancing each other, and therefore I know that the normal force is 300 newtons. It's the same amount as the gravitational force. There is a force opposing the motion of the sled, and that's the friction force that's being exerted on the sled by the floor. In this case, because the sled's moving at a constant speed, I know that that friction force is just balancing the applied force, and so it is 50 newtons. Okay, so we understand the situation of the forces on the sled. Let's determine the coefficient of kinetic friction. I'm going to start by writing the equation. The kinetic friction force equals the coefficient of kinetic friction multiplied by the normal force. Now, in this case, I know both the friction force and the normal force, and so I can go ahead and solve for the coefficient of kinetic friction. It's going to equal the ratio of those two forces. It'll equal the kinetic friction force divided by the normal force. So that will be 50 newtons divided by the 300 newtons, and that's 0.167. Notice that the coefficient of friction is a dimensionless quantity. There are no units on it. Okay? Then the question is, what would be the acceleration of the sled if the coefficient of kinetic friction were zero? Okay? Well, if there were no friction, then the net force in the horizontal direction would equal the applied force, right? There would be no opposing force, and therefore that net force would be 50 newtons. And we know that acceleration equals the net force divided by mass. That's Newton's second law. I guess I do need to find the mass of the sled. That's going to equal the weight of the sled divided by 9.8. So 300 divided by 9.8 is 30.612 kilograms. So now I can find the acceleration. It's going to be the 50 Newton net force divided by the mass of the sled, which would be 1.633 meters per second squared. Okay, let's go on to the next problem. Here we have a small lab mass. That's this small mass right here. And it is attached by a string that's rising over a pulley to a 4 kilogram block that is sitting on the table. And so we're going to do a force diagram for this block. So this is what we're doing the force diagram for. Okay, I'll do that over here. Okay, so I'll start with the weight of the block, which is 4 times 9.8, so that's 39.2 newtons. And the table is supporting the block with a normal force. And in this case, the normal force and the force of gravity are equal because they are just balancing each other. The string over the pulley is applying a tension force on the block, and that tension force equals the weight of that 1 kilogram lab mass. So it equals 1 times 9.8, which is 9.8 newtons. Now the block is trying to slide against the table, so there is a friction force being exerted on the block by the table, and I don't think we know yet what that is. Okay, so it says what would be the minimum value of the coefficient of static friction if the block remains motionless. So if the block does not move, we know the net force in both the vertical and horizontal directions is 0. That would mean that the friction, the static friction force, would be equaling the tension force. They would just balance each other. The static friction force is the coefficient of static friction times the normal force. Therefore, I could solve for that coefficient of static friction. It would be the ratio, the tension force divided by the normal force. (9.8) divided by 39.2, that's 0.25. So if the coefficient of static friction were 0.25, in this situation, static friction would be large enough to balance the tension force, and therefore the block would not slide. Okay? But what if the coefficient of static friction were something less than 0.25? Let's say it was 0.2. And the coefficient of kinetic friction is 0.18. What would be the acceleration of the block? Okay, well in this case, the block will slide because the tension force is going to be greater than the maximum static friction force, right? Because 9.8 is going to be greater than the 9.8 is greater than 0.2 times 39.2. Let's see what that is. 0.2 times 39.2 is 7.84. Okay, so therefore the block will slide. Since it slides, the acceleration is determined by the kinetic friction, right? The object will be in the realm of kinetic friction. So the net force in the horizontal direction will be the tension force minus the force of kinetic friction, which will be 9.8 minus 0.18 times the normal force, which is 39.2. So the net force will be 2.744 newtons, and the acceleration will be the net force divided by the mass. I believe that mass was 4 kilograms. Yes, it's a 4 kilogram block. Oh, but in this case, both the block, the green block, and this blue lab mass, they are tied together, joined together by this string, and they are both accelerating at the same rate. So in this case, the accelerating mass is going to be the 4 kilograms plus the 1 kilogram. Okay? Because both the lab mass and the block accelerate. Okay, and so we've got 2.744 newtons divided by 5 kilograms. And so we have an acceleration of 0.5488 meters per second squared. So the important thing to remember here is that if it slides, if it moves, acceleration is determined by kinetic friction.